Inverse functions. An inverse function exists if and only if the function is one-to-one. Now, that might mean that it is one-to-one, something like that, or that it isn't, but we restrict the domain. There'll be more on this later. The domain of the original function will be the range of the inverse function. The range of the original function will be the domain of the inverse function. This is a really important point which we will return to. Many test and exam questions can be answered just knowing that fact. Finding the inverse of a function. Write the given function using y instead of f of x. Interchange y and x. Rearrange to make y the subject of the formula. Replace the y with f-1x, which is the notation for the inverse function that we've met before. Don't panic. It's easier to see it working in examples. I've got a couple of notes here. Note, for a function and its inverse, if we do the composite function f(f) minus 1 of x, that will be the same as doing it the other way around, and it would be equal to x. And the whole idea is here that you start with x, and let's say in this example we just say we do f first, so we get f of x. Well, the inverse undoes that. It's the opposite, so it's going to map us back to x. Note, the notation f minus 1 here does not mean the reciprocal. F minus 1x is not equal to 1 over f of x. It is unfortunate that it is the same notation, but we need to get used to it, and the context should tell us what we're doing. Note, when graphed, a function and its inverse are reflections of each other in the line y equals x. We'll look at this shortly. Now, I'm repeating this. The range of f of x is equal to the domain of the inverse function. The domain of f of x is equal to the range of the inverse function. We can see that in the diagram. So this one is f, and this one is the inverse. So f has its domain here and its range, and because the inverse undoes it, it's going to map the domain back to the range.